Imagine a world so bright it looks like a mirror floating in space. A planet that does not simply glow, but reflects light so strongly that astronomers on Earth can measure its shine from hundreds or even thousands of light years away. What makes a planet reflect so much light? Could a world really be made of clouds of glass or shining metals? And is there a planet out there that reflects more light than any other? Today we are exploring the most reflective planets known to science, from our solar system to distant star systems, and how NASA's research has helped uncover these extraordinary mirror worlds. To begin, we need to understand a simple concept: albedo. Albedo is the fraction of light a surface reflects. A perfect mirror would have an albedo of 1. A dark rock would have a low albedo, absorbing most light. Planets sit somewhere in between. Their brightness in the sky depends on their size, distance, and most importantly, their albedo. When we talk about the most reflective planet, we are asking which world sends the highest percentage of incoming light back into space. Let's start close to home. Venus is the brightest planet in our night sky. After the Moon, nothing natural shines more strongly to the human eye. Venus has an albedo of about 0.75. That means it reflects roughly 75% of the sunlight that hits it. No other planet in our solar system comes close. The reason is Venus's atmosphere. The planet is wrapped in thick clouds made primarily of sulfuric acid. These clouds form a global reflective blanket. Sunlight hits the cloud tops and bounces back into space, giving Venus its brilliant white glow. NASA and other space agencies confirmed the structure of Venus's atmosphere through decades of missions. Early probes in the 1960s and 1970s revealed the dense cloud layers. Later, NASA's Magellan mission in the early 1990s mapped the surface using radar, showing that beneath the bright clouds lies a rocky world. But here is the twist. Although Venus reflects most sunlight, the small portion that enters the atmosphere gets trapped. This causes a runaway greenhouse effect. Surface temperatures reach around 460 degrees Celsius. It is hot enough to melt lead. The brightest planet in the sky is also one of the most hostile environments in the solar system. So, within our planetary neighborhood, Venus is the undisputed champion of reflectivity. But the story becomes even more exciting when we leave the solar system. In 2009, NASA launched the Kepler Space Telescope, a mission designed to find exoplanets by measuring tiny dips in starlight as planets pass in front of their stars. Kepler revolutionized astronomy. Over its mission, it discovered thousands of exoplanets and revealed that planets are common throughout the galaxy. Among those discoveries was a strange world called Kepler 7b. Its discovery was announced in January 2010. Kepler 7b is a gas giant larger than Jupiter, but surprisingly low in density, like a puffed-up balloon. What caught scientists' attention was its brightness. Kepler 7b reflected far more starlight than expected for a gas giant. In 2013, NASA announced that data from Kepler and the Spitzer Space Telescope allowed scientists to map cloud patterns on Kepler 7b. This was the first time humanity had ever produced a cloud map of a planet outside our solar system. Those clouds appear to be made of silicate particles. In simpler terms, tiny grains of rock or glass floating high in the atmosphere. These particles scatter and reflect starlight efficiently, giving Kepler 7b a surprisingly shiny appearance. This discovery was historic. It showed that alien planets could have cloud systems made of materials completely unlike water clouds on Earth. It also showed that reflectivity can tell us about atmospheric composition, weather, and circulation on distant worlds. Another famous exoplanet studied by NASA is HD 189733b. It was discovered in 2005, but in 2013 NASA announced something remarkable. This planet appears deep blue in visible light. Not because of oceans, but because its atmosphere scatters blue wavelengths more strongly than red ones. HD 189733b is a gas giant orbiting extremely close to its star. Its atmosphere contains silicate haze particles that scatter light, giving the planet a blue tone. Although it is not the most reflective planet known, it became famous as the first exoplanet whose color was directly measured. NASA's Hubble Space Telescope played a major role in these observations. Hubble has allowed scientists to analyze starlight passing through exoplanet atmospheres, revealing their chemical makeup and scattering properties. This is how we learn what clouds are made of light years away. As exoplanet science progressed, an even more extreme world entered the spotlight. In 2020, astronomers announced the discovery of LTT 9779b, an ultra-hot Neptune-type planet. Follow-up studies published in 2023 revealed that this planet may have one of the highest albedos ever measured for an exoplanet, around 0.7 or higher. That is roughly comparable to Venus. This is extraordinary because LTT 9779b orbits extremely close to its star. Dayside temperatures exceed 2000 degrees Celsius. Under such heat, many materials would vaporize. Yet scientists believe this planet hosts bright clouds made of mineral particles, possibly silicates or metal compounds, that reflect huge amounts of starlight. LTT 9779b challenges existing atmospheric models. How can reflective clouds survive in such extreme heat? How do winds transport particles between the day side and night side? These are active questions in planetary science today. Now we arrive at the big question: what is the most reflective planet in the universe? Within our solar system, Venus holds the title. Among known exoplanets, LTT 9779b is currently one of the strongest contenders for the highest measured albedo. But the truth is, we have only measured reflectivity for a tiny fraction of all planets that exist. Our galaxy likely contains billions of worlds, many with atmospheric conditions we have never imagined. Future NASA missions and international telescopes are designed to measure exoplanet reflectivity more precisely. The James Webb Space Telescope, launched in 2021, is already providing detailed atmospheric data. Upcoming observatories will measure reflected light directly from smaller, Earth-like planets. In the coming decades, we may discover worlds that make Venus look dull by comparison. Reflectivity is more than a brightness contest. It helps scientists understand planetary climate. A highly reflective planet absorbs less heat. A darker planet absorbs more. On Earth, ice caps play this role, reflecting sunlight and stabilizing climate. When ice melts, Earth absorbs more energy and warms faster. By studying albedo on distant worlds, scientists learn which planets might have stable climates and which are extreme furnaces or frozen wastelands. There is even a more speculative idea. Some scientists have suggested that unusually reflective objects in space could hint at artificial structures built by advanced civilizations. Large solar collectors or reflective surfaces in orbit could theoretically create unnatural light signatures. No confirmed evidence exists, but the idea adds a layer of mystery to the search for bright worlds. So picture it. A brilliant Venus hanging in our sky, hiding a molten surface beneath shining clouds. A bloated gas giant with glass clouds reflecting a distant sun. A scorching Neptune-like planet that glitters despite impossible heat. Or an icy world far from its star, coated in frozen brightness. These are mirror worlds, beautiful, strange, and often deadly. The universe is filled with light, and planets, in their countless forms, decide how much of that light they will keep and how much they will send back into the cosmos. Venus remains our local champion. LTT 9779b is a current record holder among distant worlds, but somewhere out there, orbiting a star we have not yet studied, may be a planet that reflects more light than any other known world. A true cosmic mirror, and the search for it has only just begun.